So today we are factoring multi-level cubes or multi-step cubes. I don't remember what I called it. Um, you'll figure it out. Today is the 18th, and you will struggle very little with today's assignment, assuming that everything to this point has gone well. So these are, we'll call these multi-step. I gave you a Delta math assignment, and just so you know, it's going to look a little bit different because I handpicked all the problems. So normally in Delta, you all do different problems, but in a case like this, you'll all have the same 10 problems in a row. And that's just because I wanted to make sure that every problem worked out the way I wanted it to. This particular bank of problems in Delta had a lot of fluffers that didn't have multi-steps. And to eradicate those, I had to go in and handpick what I wanted. So when you get into Delta here in about 10, 15 minutes, you'll look at it and go, whoa, it looks weird. It's just that way. That's how it is when I handpick individual problems. So rather than like one thing that you click on, there'll be like problem number one, and then you have to re-click on problem number two. And so if you've ever seen it before, you'll know what I mean, just so you know. Anyhow, I have three examples. So just so you can get your head around this, uh, the first one is x to the sixth minus 729. And by the way, there are no GCFs today. I'm still kind of a day or two away from the full package deal where we take it all the way to the end and say, okay, now we've got cubes spawning squares, spawning cubes, plus a GCF out front. But we're not, so like I said, probably Wednesday or when we'll see that. So this, what is this? It's a difference of cubes, right? No doubt about it. And I got to train myself to recognize those things. That 729 is clearly a cube, right? And so I'm going to say that A is equal to the cube root of that, and B is equal to the cube root of that, right? What is A? It would be x to the second power. And so we've not really gone down this road yet. So let me tell you that when your values have exponents, if you want to cube root them, you actually divide the exponent by 3. Okay, that rooting and exponents and all that, it's what an interesting relationship they have. But it's very easy to prove. I mean, if you wanted to see it from the other end, you could easily prove that x to the second to the third is x to the sixth. So conversely, it ought to make perfect sense why going the other way, we wind up dividing by 3. So that's your takeaway from that little portion of the lesson, is divide exponents by 3 to get cube roots. You'll want to know that. We are not cube rooting 6. We are dividing him by 3, which, because he's an exponent, serves the purpose of cube rooting. Go figure. What about 729? That's a 9, and so B is 9. So at this point, now that I have my A and my B, I can just plug them into the short set, long set template, right? So short set, long set, I'm going to get it set up, is going to look like this. Short set, long set. What goes in short set? Yeah, A minus B. Good. And then what goes in long set? X to the fourth. Remember, that's where we put A squared, and x squared squared is x to the fourth. Then what? Right? Just like that. So normally, like on your last quiz, this would have been worth full marks, right? You would have gotten perfect little star or something like that, and yay. But what, of course, do we now see? What did you say? Yeah. So could you be more specific? You said it, not both sides. What I was really hoping someone would identify is say something like, and I shouldn't expect this on a Monday morning, but I was expecting someone to raise their hand and say, hey, that's a difference of squares, right? And so I need to identify that, and let's attack him first. What is he when we break him down? Perfect. So we have a now x plus 3, x minus 3. And then the long set is x to the fourth plus 9x squared plus 81. And that concludes this. Could someone shut the door, please? That concludes this problem. So I'm going to say something right now that is a partial lie, but it's sort of a kind of a guarded lie. You will not be able to factor long set. And if a college professor heard me say that, then they would probably get upset. But I'm telling you, for the sake of what we're up to, don't try to factor long set. And I'll show you in a minute that there are actually exceptions to that. But understanding how to do it from where we sit is not something reasonably that we're going to talk about. So when it comes to this problem's over because x to the fourth plus 9x squared plus 81 is a dead factor. So that's the end of that. So far, so good. Okay. I have one more that's very similar to that, kind of, and then the harder one, the one that inspires the most confusion and discussion, is the third example. So anyways, that's it for the first one. And these three examples should safely, easily get you through tonight's assignment. Tonight's assignment is 10 problems. Yeah, 10 problems, and I think they're pretty straightforward. So what is this? It's a difference of cubes. Very good answer. It's a difference of cubes. And as soon as I look at it and identify it, then I plan my attack. And when I say difference of cubes, I immediately kick into AB mode. What is A? X to the third. Remember, we're dividing exponents by 3. What's B? 8, because the cube root of 512 is 8. And at this point, I go on and head in with my short set, long set, and I'm ready to rock it. It goes in short set. X to the third minus 8. That's just a simple A minus B. What goes in long set? X to the sixth plus what? 8x cubed plus what? Just like that. And again, the purpose of today's lesson is I'm trying to put like a step in between where we were and where I want to go. Today is just like our let's get acclimated to this kind of day. That's what we're doing, is we're seeing now that there's one extra step. And my job is to identify that guy. What is he? He's another difference of cubes. And so a difference of cubes has spawned another difference of cubes, who now in his own right is a let's find A, let's find B problem. So what is A? Correct. And what is B? Correct again. Good. And so what I'm going to build now is off of what I have underlined in green. I'm going to build a brand new short set, long set, and I'm going to copy the original long set. And as I said, do not try to factor long sets. Once you find one, it's dead. And that's a lie, but it's a lie that we're going to live with for now, okay? So long sets are dead. My next example, for those of you who when I say things like that want to know what I mean, my next example will hopefully show you the answer to that question. In the meantime, let's finish short set, long set. What's my short set going to be? And what's my long set going to be? Right, so that's the kind of thing you can expect today. This last one, I saved it for last because it can be done 2 different ways. They're both correct. 2 different ways, they're both correct, but one is better. All right, so I'll coach you through that, and I would hope that you would choose the better method, although the other one is acceptable as far as correctness is concerned, which is weird. Normally, math isn't like that. So what is that? I agree. What else is that? Yes. So I want to show you that this problem can be done 2 different ways. I don't expect you ever again to do it both ways, but I'm going to do it with you both ways. So if I do it the way Bryce said to do it, he said that's a difference of 2 cubes. And if I do it his way, so I'm going to draw a little curtain here, and I'm going to do it the Bryce way. If I perceive it as a difference of 2 cubes, my brain goes into short set, long set, A-B mode, right? So if I'm doing it the Bryce way, and again, this is difference for your notes, we're doing it as a difference of cubes. So I kick in and I say, okay, if that's my thinking, I need to commit to the plan. A is what? X squared. B is what? Correct. So I just instinctively kick into short set, long set mode, and short set will be what? And long set is? Mm-hmm. Mm-hmm. Plus one. Notice anything there? There is a difference of squares right at the beginning. So I'm going to factor that down. I'll underline it in green for you. This is a difference of squares. If you struggle to see that, stop. Stop struggling. Make yourself practice. Force yourself to say difference of squares, difference of cubes, sum of cubes, whatever. You got to know them quick so you can make your plan. And so what I have underlined in green up here is going to break into x plus 1, x minus 1, and then the long set. And on this side of the curtain, that is a completed answer. As you're going to see here in a minute, my lie will be exposed. Those of you wanting to know, why would you lie to me? I don't know what you mean by that. When we do this problem the way Sutter said, and that is to observe this not as a difference of squares, but as a difference of, or excuse me, not as a difference of cubes, but as a difference of squares. And you'll see it's different. And you will know coming away from this, which is by definition the better choice. If you have a choice, there is a better one. So let's do this. If it's a difference of squares, I don't need A and B. I just do my simple algebra 1 kind of thinking. What's the square root of x to the 6th? So I put x to the 3rd here, x to the 3rd here, and what's the square root of 1? So I put 1 here and 1 here, stick a plus in one, stick a minus in the other. And right away, you're like, well, that's so different. Like, it doesn't even look the same as what we did in the first step of the last one. What do you see? There's a difference of cubes and there's a sum of cubes. Very good. And so when I perceive that, I go, oh my God. So what I see now is a lot of potential for breakage. So I'm going to take my first one, I'm going to underline it in green, and that is called a sum of cubes. And I need to find A and I need to find B. What is A? What is B? Good. Now what I have underlined in red is a difference of cubes, but I still need to think about A and B. So over here, what's A? What's B? Right? Very similar, right? The thinking and the patterning of this is going to be eerily similar. Like the A squared, B squared is going to be the same, but we're going to have 4 sets of parentheses now. And so let's do the green one first. So out of the green underlined, we're going to have its own short set, long set. And then out of the red, we're going to get its own short set, long set. So this is the structure of what should be our final answer. So green guy is x plus 1, yes, times. Yeah, without signs, I don't want anything. So minus the 1x and then what? Plus 1. The cube formula always says there will be 1 minus, right? And we've used it, so we're done. How about red guy? What's he? X minus 1 plus 1x plus 1. Now, I don't mean to insult your intelligence because if this is obvious, it's never my intent to do that. But when you look at these two answers side by side, just follow your instincts here. Which one of them has to, by definition, be the better answer? The one on the right is better. Why? What's the point of factoring? To break it into pieces, as many as possible. And when I do the cube method on the left, I'm limited by what I'm able to see. By choosing cubes in the first step, I forced myself to only be able to break it down into, let me use some color coding for you here. Both sides have x plus 1. Check. Both sides have x minus 1. Check. However, through some magical, and if you're a very mathematically inclined person, you should try this. I'm not going to, but you should take the things I'm about to underline in yellow, this times this, and multiply those together and verify, I'll be darned, they actually equal this. By definition, you should choose the difference of squares, and there will be 5 of them. Half the problems on today's assignment, you'll have a choice. Delta Math would accept either the white answer or the red and green answer, but you should choose the difference of squares because if we're going to do it, let's do it the best that we can, right? And breaking something into 4 pieces is better than breaking it into 3. You would agree. So that's that. Do you have any questions about any of that? So you're going to do 10 of those on Delta. And then for those of you who are not done, which is almost all of you, I think, then you're going to go back and also get back to work on assignment 6, maybe, or whatever the one was that we worked on Thursday. Okay. I'll leave the recording going. And if anyone has any questions, I could do a problem on the recording. So I'll just pause it.